Cancer usually does not become deadly because of the first tumor. The real danger begins when a small number of cancer cells escape. One cell breaks away. It squeezes through the surrounding tissue. It finds its way into a blood vessel, a tiny highway running through the body. It survives a violent, chaotic journey through the bloodstream. And then, somehow, against all odds, it finds another organ. The liver, the lungs, the brain, the bones, and it starts growing again. This process is called metastasis, and widespread metastatic disease is responsible for the majority of cancer deaths. Today, we're shrinking down to the cellular level to watch exactly how cancer escapes one organ and colonizes another. Let's begin inside a tumor. It's important to understand that a tumor is not simply a ball of identical cancer cells. It is an entire bustling ecosystem. The cancer cells are surrounded by a complex network of blood vessels, immune cells, and connective tissue cells called fibroblasts. All of this, along with various signaling molecules, makes up what scientists call the tumor microenvironment. And cancer cells are not passive residents here. They are active architects. They can reshape this environment to help themselves survive, grow, and eventually spread. As the tumor expands, some cells inside it begin to change. Through a series of genetic and molecular shifts, they accumulate traits that make them more ambitious, more invasive. They start to loosen their physical attachments to neighboring cells, like a mountain climber unhooking from their team. They become more mobile, gaining the ability to crawl and push, and they begin the process of breaking through the natural structural barriers that normally keep all the cells in our body neatly in their place. This is the first critical step: invasion. Normal, healthy cells respect boundaries. They grow until they touch their neighbors, and then they stop. It's a fundamental rule of cellular society. But some cancer cells become outlaws. They stop following the rules. They start to release powerful enzymes, like microscopic demolition tools, that digest the surrounding tissue. They actively alter the environment around them, creating tiny pathways through what's known as the extracellular matrix, the structural scaffolding that hold all our cells together. Think of it like a prisoner slowly and methodically chipping away at the walls of their cell, creating an escape route, millimeter by millimeter. Eventually, an invasive cancer cell reaches its first major obstacle, a nearby blood vessel or a lymphatic vessel. Now comes one of the hardest steps in its entire journey: getting inside. This process, called extravasation, requires the cell to be incredibly flexible. It has to squeeze itself between the tightly packed cells that form the vessel wall, contorting its shape to slip through a gap far smaller than its own body. Once inside, the cancer cell has successfully broken out. It now has access to the body's superhighway, the circulatory system. You might think getting into the bloodstream means the cancer has already won, that the hard part is over. Not even close. For a single tumor cell, the circulation is an incredibly hostile environment. It's a brutal, high-speed journey. Blood moves quickly, and the cell is battered by immense mechanical stress, constantly being smashed and sheared by the force of the flow. On top of that, the bloodstream is patrolled by the immune system. White blood cells are constantly on the lookout for anything that seems abnormal or out of place. The vast majority of cancer cells that enter the circulation die within minutes or hours. They are either torn apart by the physical forces or identified and destroyed by immune cells. This is what makes metastasis so remarkable from a biological standpoint. A primary tumor might shed millions of cells into the bloodstream every single day, but successful colonization of another organ can depend on the one rare, uniquely equipped cell that is capable of surviving every obstacle. Some manage to survive by traveling in small clusters, huddling together for protection. Others have a clever trick. They interact with blood platelets, which can form a kind of shield around them, partially cloaking them from immune attack. But only a tiny fraction survive long enough to even reach another organ. Now, cancer cells that do survive this journey don't just spread randomly. Different types of cancer tend to favor different organs, a pattern doctors have observed for centuries. Prostate cancer often spreads to the bone. Colon cancer commonly travels to the liver. Many cancers, including breast and lung, can spread to the brain. Why this specific targeting? Part of the answer is simple logistics, a matter of blood flow. The liver, for instance, filters a huge amount of blood from the digestive system, making it a common destination for colon cancer cells. But there's another, more fascinating idea called the seed and soil hypothesis. First proposed over a century ago, it suggests that the cancer cell is the seed and the distant organ is the soil. A seed can be carried by the wind and land almost anywhere, but it can only germinate and grow where the soil is fertile and provides the right conditions. Researchers now know this is incredibly accurate. Cancer cells interact intensely with the microenvironment of the organ they enter. A breast cancer cell might find the environment in the bone uniquely supportive of its growth, while it would quickly die in the muscle. In a stunning twist, we've also learned that some primary tumors can send out molecular signals ahead of time, like scouts preparing the ground, to make the soil in a distant organ more hospitable before the metastatic seeds even arrive. Our surviving cancer cell has now traveled across the body and slows down inside a tiny blood vessel, a capillary, in a new organ. Here, it must perform its breakout maneuver in reverse. It attaches firmly to the vessel wall. Then, once again, it squeezes its way out between the cells of the vessel. This escape is called extravasation. The cell has now completed an extraordinary multi-stage journey. It started in the original tumor, pushed its way through surrounding tissue, broke into the circulation, survived that deadly highway, traveled across the body, and has now emerged into a completely different organ. But arriving is not enough. Now comes what is perhaps the hardest step of all: building a new home. Many of the cells that successfully complete this journey simply die after reaching a distant organ. The new environment is too foreign, too hostile. But others do something different. They survive, but they stop dividing. They enter a quiet, inactive state called dormancy. Years can pass, sometimes decades. A patient may have had surgery to remove their primary tumor, followed by chemotherapy. Their scans might show no detectable cancer anywhere in the body, and for all intents and purposes, they are cancer-free. Yet, a tiny population of these dormant, sleeping cells may remain hidden somewhere in the body. Then, for reasons scientists are still racing to understand, some of these cells can suddenly reactivate. They wake up and begin growing again, forming a new tumor years after the initial treatment. This is why a cancer can sometimes return long after everyone thought it was gone. Here is an important detail to understand. If breast cancer spreads to the lungs, it does not become lung cancer. The new tumor that grows in the lung is still made of breast cancer cells. If prostate cancer spreads to the bone, it is metastatic prostate cancer, not bone cancer. This is critical because doctors treat metastatic tumors based largely on where the cancer originally came from, its cell of origin, and its unique molecular characteristics. So this entire microscopic drama begs a very human question. Can you prevent metastasis? There is no lifestyle trick that guarantees a cancer, once formed, will never spread. Preventing metastasis depends primarily on two things: early detection and appropriate medical treatment. The goal is to treat the cancer before it has had the chance to send out these pioneering cells. But you absolutely can take steps to reduce your overall cancer risk and to increase the chances of finding certain cancers before they have a chance to spread. This includes things like not smoking. Tobacco is one of the single most preventable causes of cancer. Staying up to date with recommended cancer screening, like for colorectal, breast, cervical, or lung cancer, can detect disease at a much earlier, more treatable stage. Knowing your family history, maintaining a healthy weight, staying active, and limiting alcohol are all associated with a lower risk for several cancers. And finally, not ignoring persistent, unexplained symptoms. Things like unexplained weight loss, a persistent lump, a changing mole, or a prolonged cough deserve medical evaluation. Most of the time, these symptoms won't be cancer, but early evaluation matters. So, how does cancer spread? It's a story of survival against impossible odds. A single cell escapes the primary tumor. It invades the surrounding tissue. It breaks into the blood or lymph systems. It survives the brutal journey through circulation. It finds a compatible organ, the right soil for its seed. It exits the vessel, it evades the new organ's local immune system, and finally, after all that, it learns to survive and thrive in an entirely new environment. Each step in this cascade is extraordinarily difficult, and most cells fail. Yet when even one cell succeeds, a new tumor can begin. That is metastasis. And understanding this perilous journey explains why detecting cancer early and treating it before it has a chance to disseminate can be the most important factor of all. Because in the end, cancer doesn't need millions of cells to escape and start a new colony. Sometimes it only needs one survivor. Subscribe to Cell-Wise Health, where science meets everyday health.